let's talk about Bernoulli's principle and Bernoulli's equation that comes from it. Now, I will not be deriving the equation in this video. Please feel free to hit up YouTube or your favorite learning website to see how it's derived if you're interested. The equation looks like this. And honestly, to me, it reminds me a lot of a conservation of energy equation. So if we're adding together the initial kinetic energy in the system, the initial gravitational positional energy, we're summing those up. And we say that the initial values for the sum of all those energies equals the final values of the sum of all those energies. This is really reminiscent of that. Let's get into it and explain what the parts are and the context for Bernoulli's equation. Now, Bernoulli's equation is used as a way to describe how airplane wings generate lift, how fluids flow in pipes, etc. I'm going to use fluid flowing in a pipe just to be an illustrational example, though know that it does have multiple contexts. I've got water flowing in a pipe from left to right in this picture. So we're going to send water in this way, and water's going to come out this way. So the Bernoulli's equation talks about the left side, a section of water in the left side, the input or one side, and then the output side of the pipe. You'll notice that in this problem, the pipe changes height levels. That's another context where Bernoulli's is a useful equation to solve. Let's dissect this. Pressure 1 is the input pressure on the left side of the pipe. This 1/2 density velocity of the fluid squared, that sure looks a lot like the kinetic energy equation, 1/2 mv squared. And it does come from that. So this relates to the kinetic energy density of the fluid at that lower left section of the pipe. Then we're going to add to it some sort of gravitational related energy density of the fluid. This is density of the fluid, gravitational field strength, and the height at the lower level. So I've got a height at the lower level. That's described here as h1. Sorry, I've used y in my equations. Please forgive me. Let's make this y1 and y2. It's important when solving Bernoulli's equation problems that you identify initial and final heights, initial and final points in the problem, So like we're going to talk about the problem here versus here, and that you identify a zero line for height. In a lot of the problems I've seen, we often will identify the zero level here on the left side, or conveniently on the right side, depends on what's easier for you. That way one of these heights gets to be 0. In the next video, I will present to you an example of Bernoulli's equation to solve a pretty straightforward problem. Onwards to the next one. Good luck and happy problem solving.